Okay, so after we've done this ball and connector activity, you have the following chart in your notes, and we're going to fill it out. So go ahead, find your chart. And I want you to draw the following pictures for each. So we looked at an atom. So we made our classifications. We have an atom, we have a diatomic molecule, and we have molecule of a compound. So with that atom, it's just a single, by itself, alone atom. So what I want you to do is underneath atom, I want you to put single. It's alone. And notice that alone starts with A, so maybe that'll help you think of atom. There are no bonds. So there's no connectors. And it's found on the periodic table. Now if we look at diatomic molecules, there are bonds, so there are connectors. They are twins, so they're a duo. Duo starts with D, just like diatomic molecule. And when we look further into that periodic table, they end in gin or -ine. And there is 8 of them. So we have just a couple. We have nitrogen, we have oxygen, we have bromine. So there's a couple there. Oops, it's supposed to be 2. There we go. Now, compounds. Compounds also have bonds. So they have those connectors. But there are different atoms. So notice that diatomic elements are the same. Compounds have different atoms bonded together. Okay, so they are combined, different. So here that helps me think of compound. Combined starts with a C, and then compound ends with a D for different. Combined, different. Diatomic molecules are duos, they're twins. And an atom is all alone, no bonds. All right, so atoms are found on the periodic table. Diatomic elements are not shown on the periodic table as they are. So with the diatomic element, if we were to break those bonds and look at one of those single atoms, then yes, it is on the periodic table. However, with them bonded together, they are not. And compounds are formed when atoms bond together, so they're also not on the periodic table. So here is an example showing bonds. And these, sorry, those lines should be faced going that way. So looking at this one, is this an atom, diatomic element, or a compound? It is a compound because we have different atoms bonded together. Which one is this? Atom, diatomic element, or a compound? This is a diatomic element because they are the same. So they're twins. So we have a diatomic element. And this is hydrogen. So here we have iron is an atom, diatomic element, or compound. So these are atoms. There's no bonds. They're all alone. All right, atom, diatomic element, or compound? If you guess compound, you would be correct. These atoms are different, and they're bonded together. Atom, diatomic element, or compound? They're a diatomic element. They are the same. We have chlorine. So that's Cl2. There's two of them. All right, so looking at matter, we can also classify it between pure or impure. So for pure, they're going to be all the same elements. Impure, there's going to be different elements. So if you want, you can go ahead and draw this picture out. So what are some examples of pure and examples of impure? Well, some examples of pure we can think of. Let's just go to the next one. Okay, so what are some examples of pure? So we can think of deionized water. We can think of aluminum. So those are substances that contain the same element or atom throughout. Examples of impure would be salt water, because we have salt and water. Air, because there's many different gases in air, including some pollutants. So there's a couple. So with pure, we can break that also further down into elements, compounds. So elements cannot be broken down into simpler substances. So for example, aluminum. Compounds can be broken down into simpler substances. So if we looked at that deionized water, that's broken into hydrogen, there we go, and water. So this is a compound, whereas aluminum is just that single element. So here is another picture that you can draw. So a pure element would be lithium. A pure compound would be propane. Here's more examples of elements. So those diatomic elements, they are the same. So here we have chlorine. And then over here, we have two different atoms. So this is the example of a compound. And if we were to write that out, it would be HCl. And another way to help us distinguish if we have a compound is we are going to have two different capital letters. So we have the capital H, capital C. Okay. Your turn. Can you list some elements and some compounds? So we looked at pure. Now let's take a look at impure. So impure can be broken up into homogeneous mixtures, also known as solutions, so AKA, and then heterogeneous mixtures, also known as mechanical mixtures. So homogeneous is a mixture with only one phase throughout. So you can't tell if there's any other little floating particles. So we can think of apple juice or blood. So it looks similar throughout. Whereas a mechanical mixture, you can see different chunks. So chicken noodle soup. We can see the noodles, we can see the chicken, the broth, any kind of flavoring. Another example would be pizza. You got like a pepperoni pizza. You can see that cheese, you can see the pepperoni, you can see the sauce, the crust. So that'd be an example of a mechanical mixture compared to solutions. So more examples of homogeneous mixtures. Your solutions would be salt water because it looks the same throughout. Whereas an example of a mechanical mixture would be oil and water. It separates and you can see the oil from the water. All right, more examples of homogeneous mixtures. So those solutions, vinegar and Kool-Aid because it looks the same throughout. And here is a picture just to represent homogeneous and heterogeneous at that molecular level. So homogeneous, we do have different particles, we have different elements, different atoms, but they're mixed nicely together. Whereas the heterogeneous mixtures, notice how we have this separation, so we can see the different chunks. So now going back to those pure substances and impure substances. So pure, we have the same element throughout. So here's the same element. And then for a compound of a pure substance, that's all we have, the exact same compound used over and over. But if we take a look at mixtures, so these are impure. Here we have homogeneous, so we have different atoms, and it's mixed nicely together. Whereas the heterogeneous, we have these little sections, so I can see the chunks. Here's more examples of the heterogeneous mixture. So salad or salad dressing, you can see that separation. And then in your notes, I want you to find this concept map and I want you to create it. So matter can be classified into two sections. We got pure and we got impure. Pure is only one type of particle. It can be an element or a compound. And impure is more than one type of particle mixed together. So that could be as a solution or a mechanical mixture. So for the element, there is only one type of atom. And if it was a compound of a pure substance, you'd have only one type of compound. Or only one type of that molecule. For a solution, it looks the same throughout. And that mechanical mixture, you can see the different pieces. So I want you to fill this out. Different pieces. Good.